In the last video, we actually acquired our data points. We also found that our mass of the mass of the ball was 16 grams, and the mass of the tube was 118 grams. And so if we just take a look at our data set, we're not really concerned with what's happening in the x direction. It's pretty consistent. We could, if we want to magnify, but let's not talk about that right now. Let's just go ahead and get what's happening in the y direction. So the only thing that we're concerned with are these displacements. So this is one displacement, another one, another one. We're going to take all these displacements, average them, and then, yeah, we're going to just average them. So just going to say done. And I'm going to share this video with points. Make sure you share the video with points to Dropbox, and that'll be fine. And we're going to move our data file over. All right, before I move this data file over, I want to clean up my Dropbox a little bit. I have some things in here that I should not have right now. It's like the Ballistic Pendulum. I have this in here already. I have the data set in there already. I have this Ballistic Pendulum data set. I just want to go ahead and get rid of that because that's what I'm about to bring over. And you're not going to have these things. And I also have the initial velocity data set in here as well. Well, actually the calculation, and you don't have this in here as well. But you do have access to it. And so I am just going to go to this particular sheet in Microsoft Excel. You don't have, it should be blank, okay? The one that I'm opening right now. I'm just walking through the procedure for you. So under the Ballistic Pendulum, I am just going to get rid of everything that's occurring in the Y direction. So I'm just going to clear that out. This initial velocity here, this is where we're going to compare our initial velocity that we're about to calculate to the initial velocity that we calculated utilizing the kinematic theory. All right, so let's go back to video physics, not video physics, but graphical. We've already set up our table here. We want to share this with Microsoft Excel. So now this should open. You see I have myself a convert and edit, and we definitely want to convert and edit that. And we're going to put that into our ballistic file. And so you'll see that I only have one Excel spreadsheet in there right now. And let's go ahead and clean this up. Again, you will know that I am not trying to leave time in there if we don't need it. If we go back to our theory, the theory is here. Look at the theory. The theory doesn't require time at all. Just the mass of the ball, mass of the tube, and G and the Y direction. So it's just what's happening in the Y. So we don't need X. Just going to hide that. We do not need the X velocity or the Y velocity. But what we do need is this data set. So let's check our integrity here. We have 3 zeros. 1, 2, 3 zeros, and we have 2 here. So these 3 zeros are going to pretty much represent 0, and then it's going to rise a little bit. So, and then I have 2 zeros, and then I have 1 0. So this would be 0. So 0, our final position is 0, final, initial, final, initial, final, initial, final, initial, final, initial, final. That's really what I'm saying. Initial, final, initial, final, initial, final. So this data set looks good. We're going to go ahead and copy this. Well, you know what? Before we copy it, let's just go back. There's something else that we're going to need in the ballistic pendulum, out of the ballistic pendulum. So if I bring up the, what do you call it? If I bring up the template here, you'll notice that we need to have our initial velocity information here. So I'm just going to go ahead and grab that. I mean, of course, you can just go and find out what the information is, but I'm just going to go ahead and grab that. And it's the calculation that I want to have. So here's the calculation. We already have our data set in here from earlier. We do not put any data in here. I'm going to duplicate this. I'm going to move it to move this duplicate to this particular folder that we're working in, which is Brass Eric and Ballistic Pendulum. So I'm just going to save that there. I know that it's 3.1. Now I can go back to our folder, and it should pop up here. 15. Yep, there we go. So let's go ahead and acquire data again from the Ballistic Pendulum, and then we'll just put that in. And we know that our initial velocity is 3.1. I don't want you to write my 3.1 in. You write your own in. Some people have 2.8, some people have 3.2. You know, it varies depending on how you did your or performed your experiment. So I'm going to go ahead and go into our template here, paste that information. And I want you to notice that I have myself 0.008, 0.007. So this is 8 millimeters, 7 millimeters, 7 or 8. All of them are about 8. So you'll see that I'm coming out with an average Y displacement of approximately 8. And the initial velocity calculation is calculated right here. I'm coming up with 3.3. Okay? We can't get all the way down to all of these decimals. So I can just bring this down. 2 decimals, it's really just 1 decimal will be fine. But then we have our velocity coming from our kinematic theory, and I have a percent difference of 6.33. So this is valid if we use our kinematic theory as our standard. You know, this is our standard. This would be how valid our work is. Okay, this is pretty much the end of this experiment. Make sure you upload this. Try to put your last name and first name in here. That would be awesome. And we'll move on to the next experiment.